Now that we've talked about concurrency and parallelism, and you have a bit of an understanding about what those concepts mean and a vague understanding of how things work with Java and the history of concurrency and parallelism in Java, it's time to start turning our attention to the main focus of the course, which of course is how to program concurrent and parallel applications, system applications in Java. And we're going to start our discussion with a focus on Java streams. And you'll understand why we're going to focus on that initially here as we go through this. So what we'll do in this part of the lesson is talk about what Java streams are, their structure and their functionality. And you'll see, as you can witness from the visualization here, it's basically a pipeline of operations that transform data that flows through the pipeline. And I'll talk a lot about that, and you'll get a good sense of how all that stuff works. So we'll talk about the fundamentals of streams, what the basic building blocks are, which turn out to be these different types of so-called aggregate operations, so-called intermediate operations, terminal operations, sources, factory methods, all that kind of good stuff. And we'll talk about the three primary phases of a stream, which is the sort of create or split part, the apply part, and then the combine part. Now, some of these discussions about splitting and combining are really most interesting when we talk about parallel streams, which we will get to in the not-too-distant future. But we'll talk initially about sequential streams, and you'll see why as we go through this. So Java streams are a framework that was first introduced into the Java class library in Java 8, which came out in the 2014 timeframe. And this was a radical evolution for Java. Up to that point, Java had been an object-oriented programming language. And with Java 8 in 2014, it became a hybrid functional object-oriented programming language. And people often say that the functional programming features like lambda expressions and method references and functional interfaces, all the kind of stuff that we've very briefly talked about, but you could watch in other videos if you're so inclined or don't know that stuff. Those are the gateway drug to the real addiction in Java 8, which is streams. So Java streams is really where the fun stuff really happens, and everything else is there. A lot of the other new features, the functional programming features, are there to make it easier to program streams. So what is a stream? A stream is a pipeline of so-called aggregate operations that process a sequence of elements, also known as values or data. Often these elements are objects, but we don't tend to think of them as objects as much as we think about them as elements, and you'll see why as we go through the discussions a bit. So as you can see here, input flows into this pipeline and various functions are applied that transform the output. And when we're all done, we'll get the results that come from applying that composition of operators. These so-called aggregate operations are what are known as higher order functions, which is this very fancy, highfalutin sounding name. And really all it means is a higher order function is just a function that applies a function, or in this case, a function that applies a behavior that's passed as a parameter, and every element in the stream has that behavior applied to it, or at least until we get to the discussion of short-circuiting operations. So for right now, let's pretend like the operations get applied to the behavior gets applied to every element that flows through the stream. We talked, one of the key themes that you'll see a lot in modern Java is the concept of behavior parameterization. And what that allows us to do is it allows us to be able to change behavior without radically affecting the overall structure of the program. So you can have a flow of information between these aggregate operations, which we'll talk about in more detail, things like map or filter, flat map, or collect or reduce, et cetera, and you can change the behaviors without really changing the structure, which is kind of a cool idea. You can think about a stream as conceptually being unbounded. At least in theory, you could have a stream that flows forever, just like a mountain stream until the water source runs out. But in practice, it's often bounded by certain constraints, like if you're going to be creating a stream from an array list or a stream from a tree set or something, you're not going to have an unbounded stream. You'll have the number of elements that were in the original array list or the original tree set, and that will be the elements that you'll be processing in the stream. So we'll talk more about that, but you could have an unbounded stream. We're going to use a very simple little case study throughout this introduction just to kind of make the points concrete, because it gets boring to talk about these concepts in the abstract all the time. And here is the program. You can get this program if you go to the EX12 folder in my live lessons GitHub repository. And of course, as always, this material will be available online with the slides that we have. So this is the program. This program, as we're going to talk about, prints every character. I don't mean like the letter C, I mean like a person. Every person in the famous Shakespeare play Hamlet that starts with an uppercase or lowercase h, and it will consistently capitalize them to always start with an uppercase h followed by lowercase letters in the rest of their name, and it'll print them in sorted order. So that's what this program does. So what it does is it takes a list of the character names. We don't care what order they come in. We're going to get rid of any character whose first letter is not an uppercase or lowercase h. So Gertrude and Laertes and Fortinbras and Ophelia go away, but Hamlet and Horatio make it through that filter. Then we're going to capitalize everything so that the first letter is capitalized, everything else is lowercase. We're then going to sort the results, so they'll be in lexicographic order, and then we're going to say for each of the results, print the results. So that's a nice simple example of a stream in Java. Now, it turns out that streams have evolved over time. They started out very simply, and then some other things have been added to them over time, and they're very powerful at this point. There's, for example, some new operations that have been added in later versions of Java. So if you take a look at the links here, you'll find out a few more things that have been added. This, by the way, is a great book to learn about Java and Java streams, Java completable futures. It's called Modern Java in Action. And it's the textbook for the class. You're not required to get it, but it's a good idea. It's a really great book. Java 9, which came out probably in, 2016 maybe, added some new stuff. So it added a new API that implements something called the reactive streams specification. And it has a lot of things in common with Java streams, but it goes further, and it supports kind of a pub-sub-like model, and it also supports very cool asynchrony. We're not going to talk a whole lot about reactive streams in this course right away, but we will get to it later. So the first topics we'll focus on will be regular streams, and then we'll cover reactive streams later. Reactive streams is really, really, really cool. And the good news is once you understand Java streams, reactive streams aren't that hard to learn. So let's talk about the three phases that you find in Java streams. And I think I mentioned before that it's basically split, apply, combine. And you can read about split, apply, combine as a paradigm for doing scalable computing in the article at the bottom of it. So the first phase is the split phase or the create phase. And this starts with a source of data. And the data can come from various places. So you can have data that comes from an array. So believe it or not, this is actually an array. This is what's called a varargs parameter list. But basically, we're passing in a sequence of character names as strings, which is going to be essentially treated as an array. The ... is just, I don't want to write them all out, but that's not syntactically correct. It just says there's a bunch more here. So in this particular case, we're using the of factory method. You'll see a lot of uses of in Java, in modern Java, which it usually means to create something. It's a factory method. You can also make yourself, say, a collection, like a list of characters. So we have list, which is a list of characters or strings. And then you can say characters, which is the local variable, dot stream. And dot stream is the factory method that will convert the list into a stream. And we'll talk later about how stream works under the hood. It's very interesting. The next phase, once you've created the stream, is the apply phase. And this is where you're going to process the data through this pipeline of intermediate operations. And we'll see that there's two kinds of operations. There are intermediate operations and there are terminal operations. So intermediate operations are typically things that do data processing or filtering or manipulation. And examples of these would be filter, map, and sorted. So you can see filter, which only lets certain elements of the stream through. And you can see map, which has some kind of side effect to make changes to the contents. For example, it will, in this case, capitalize everything in a nice, consistent way. And then the last thing we have here is sorted, which, as the name implies, will sort things. So those are three examples of so-called intermediate operations. The intermediate operations often, though not always, will transform stuff. So you can see capitalize, transform stuff. In this case, it goes from potentially inconsistent lexicographic characters to one where they're sorted by, or they're not sorted, they're going to be capitalized consistently. And then sorted, of course, also rearranges things. These two examples for this particular case study don't manipulate or change the type. They just do something to the elements in the string. There are other operations that can change the type, and we'll talk about those later. Filter doesn't transform, it just lets something through or not. And it does not make any changes. It just decides whether or not it goes through. It's kind of like a gate. And then again, some operations, some transformations are stateless, like capitalize. Capitalize takes input in, it modifies the input and then passes it as output, but it doesn't change anything else in the stream except modifying each element individually. So it doesn't require any knowledge of history with the other elements in the stream. Every one of them is independent, is another way to look at it. Some operations are stateful. So sorted is a great example of a stateful operation. You have to get all the elements in the stream and collect them into some intermediate buffer before you can sort them, right? So it's going to have to require some state. We'll talk later about this, but in general, stateful operations are slower and take more space because they have to collect everything up into some intermediate buffer. I should also point out that these operations map the input stream to an output. So something like filter takes input, gets rid of the stuff it doesn't like, has output. So they're mapping or changing or filtering. And then the third and final phase is the combined phase, and this finishes with a so-called terminal operator or operation that yields a non-stream result. And when you look at the stream interface, you're often overwhelmed by the sheer number of methods in there, and sometimes it's hard to tell at first glance which methods correspond to intermediate operations and which methods correspond to terminal operations and which operations correspond to factory method operations and so on. And so the easiest way to tell is if something is going to return a stream, it's probably an intermediate operation or a factory. If something does not return a stream, then it's a terminal operation. And this is an example of a terminal operation called for each. And what for each does is for each element in the stream that made it this far, which are the ones, of course, that start with lowercase or uppercase h, go ahead and print the results out. And you can see here how we're using the system.out : println method reference. So this is a method reference that will be called for each element in the stream. So it will print it out with a new line for each one. Terminal operations have several key roles in streams. One is that they trigger the processing of all the intermediate operations in a stream. So it turns out that nothing actually happens in a stream until a terminal operation is encountered. And when the terminal operation is encountered, then and only then will stuff start to happen. Up to that point, then nothing happens. And that's important to remember because we're going to talk later about frequently made mistakes with streams, and one of them is to forget to put a terminal operation, in which case nothing happens. So that's one thing that they do. And then they also typically have some kind of side effect or result. So this one's going to go ahead, for example, and print out every element in the stream to the standard output. So it has a side effect. A stream will only run if it has one and only one terminal operation. So much like the famous movie, The Highlander, there can be only one. So you can only have one terminal operation. Now, you can forget to put a terminal operation, in which case it won't run. You actually cannot have more than one because since a terminal operation doesn't return a stream, you can't chain terminal operations together the way you can chain intermediate operations together. So if you try to say, for each followed by reduce, or for each followed by collect, or collect followed by reduce, it won't compile. So that'll be a good warning that you can't have more than one. But it won't remind you if you forget to put one in there. So that's the end of our first discussion about Java streams. And we'll talk a lot more about all these things, but this kind of gives you the high-level view. So the key thing to remember here is that streams are basically flows of elements, and you can have various kinds of operations, either intermediate operations that do filtering or transforming, and then you have a terminal operation which sets everything in motion and then gets the results processed somehow.